Yes, are we good? Okay. Hi everyone, getting used to hearing my echo, but good to see everyone. I'm Jack. I work for GSK, but I'm unaffiliated. I'm just an alumnus who found a bug and wanted to share it in PyRosetta. And just to get into it, just to give an outline of the talk, there's this observed behavior in PyRosetta that can cause big issues for even the slightest use case. So I'm just going to show the observation first, then back into the cause, and then show what we're doing to resolve it. And nowadays, most uses for me for PyRosetta are just going from PDB file to NumPy tensors. So that's sort of the narrative, but the bug happens in other contexts too. But you can imagine, for just the scope of a narrative, is this function generate tensors for inpainting where you have a pose. And in Rosetta, we have these residue selectors where you could select a subset of a pose that you might, in this case, want to mask out if you're changing only some of your diffusion model. You keep some of the framework, you design the rest. So you can imagine a function that starts like this, where you take a pose, you take a residue selector. The residue selector you then use as the designable positions that can be molded by your ML model. And then just the opposite of that is the fixed positions, the negation of that mask. So you'd use the not residue selector, which takes all of the ones and zeros and flips them. So this is, I don't know anybody's like PyRosetta experience. This is normal PyRosetta so far. And it's tough to visualize residue selections on a slide, so I'm just going to use like PyMol figures like this. This is a structure I worked on at UNC, and I just like to give it screen time. Because any pose works, right? So you can imagine just selecting the helix in the green chain as residue index selector in the bottom left. I hope that's at least a little bit visible. The code itself isn't character by character important here. So 35A to 55A, residue index selector selects the magenta selection. And then on the right, I'm just going to maintain the actual what happens in the code, but just visually. So the fixed residues are correctly identified as everything except that helix, and then the designable is the negation of that, and so it's just the helix. But you can cascade residue selectors into each other, so you can expand your task to design the helix and its neighbors. You can imagine using the neighborhood residue selector. You take the helix, everything within 8 angstroms, and now the magenta designable side is the helix and its neighbor. You know, it's the code and the pictures match. But you could just as easily imagine inverting the task and saying that we want to conserve the helix and perhaps its binding neighbors. And so essentially we just flip everything, and now your mask is the opposite. And you would expect this, right? The magenta would now, the selected mask is just the opposite of what we just had. And so I just went back a slide. On the right, you would just expect the flip. You would expect this, where the designable positions are everything except the helix, and the fixed positions are the helix and its neighbors. But instead, when you actually print this residue selection, you get this. Both masks actually select the same subset of the pose, and the actual code will select everything except the helix and its neighbors to be designable, and everything except the neighbors to be fixed. And so in hindsight, I do believe this has killed projects of mine over the years, and hopefully not too many of yours, but maybe some, because you don't always unit test like the plus sign or like very simple thing. Like usually when you're prototyping a project, you would think that this kind of logic works. I'll go into more detail about how this is dangerous, but very simple code can result in wrong behavior. I hope it's clear what I'm showing the issue to be, right? The mask is selecting the exact opposite of what we expect it to be selecting. And I'm going to just show all the code that resulted in this. The function I defined at the beginning is now at the bottom, and the rest is at the top. The font changed, so the equal signs don't line up like I used to like them lining up, but that's okay. Everything we looked at before is here, and I'm just going to inline the function because this mask here is the same as, oh no, that doesn't show up. Well, that doesn't matter. The mask at the top is the same as the variable called mask at the bottom, so I'm just going to clean this up, and so this is the entirety of our code that gives the issue. And the designable positions at the bottom gives you what you want. The fix doesn't, so the bug happens somewhere there. I don't know if I want to give people a reason. I don't know if I'm making a puzzle out of this or not. I think I'm just going to jump to what the problem is. And it has to do with the C++ under the hood. I see Andy nodding. I'm trying to make this approachable to people who don't know both languages. In C++, you can have like multiple equivalents of like the underscore underscore init underscore underscore that would be in Python. We call those constructors. And so these are constructors for the NotResidueSelector, and the top one copies the input argument, and the bottom one sets a variable called selector, the thing to be negated. It sets the input selector that will be negated. So these do opposite things. So when we construct this final NotResidueSelector, we have these two different constructors to choose from, and that happens dynamically based on the type that you're inputting. This is slightly dangerous in C++, but you can write your code to always guarantee that you're calling the right one. Like, there's rules about this. When you go into Python, like the difference between a const ref, the ampersand on the top, and a COP on the bottom, like those wash away, and they're actually very competitive against each other when it comes to overload resolution. When we started at the beginning of the slides and we were just selecting the helix and passing that as the mask, the residue index selector class itself is being passed in as the argument. That is a subclass of the residue selector. COP is just a boilerplate type def in C++. And it's not a subclass of the NotResidueSelector. So the overload resolve logic can only match the bottom one. So we call the setter constructor when our mask is the helix. Same for the helix neighbors. Neighborhood residue selector cannot resolve to NotResidueSelector. So it definitely calls the setter, which is what we want. But now when we negate the neighborhood residue selector, our mask is a NotResidueSelector, which is still a subclass of the bottom one of the residue selector, COP, but it's also the direct class of the top one, and the overload resolution logic will take the most specific match, which is now the top one. So we've now switched which code we call, and in this case, it's the exact opposite of what we want. So I'm just going to jump into what we're doing to fix it. For all PyRosetta copies prior to this past September, this is the correct way to construct a NotResidueSelector. If there's any chance that the input mask would be also itself a NotResidueSelector, you just call the default constructor with no arguments, and then call the follow the setter in a subsequent line. These slides are going to be shared, so you can't note down code, but please do this in all your code just in case you're using old checkouts of PyRosetta. This is also happening for other classes. I think the neighborhood residue selector itself has this issue. When you pass in a neighborhood residue selector to a neighborhood residue selector, it's unclear if you want a neighborhood of that neighborhood or a copy. There's a list online, so I'll just leave it at that. So for old PyRosettas, for almost any class, really any class in PyRosetta, if there's one input argument and it could possibly be the same class that you're constructing, even if it's abstracted away, you're in danger to a degree, unless you're intending to copy. Even then, it's still kind of dangerous, so just something to know. I'm repeating myself a little because I'm very frustrated because I do think I've fallen into this at least 5 times a year for my whole career. So, so addressing the problem in the actual code base, Sergey and Rocco have helped a lot, especially, I wish Sergey was here because he should get a lot of credit for this. We had a pull request in September. Sergey might be the only person that can fully read the text here because this is what tracks the binding process from C++ to Python. But essentially, the 3 green lines just subtract the function of the copy constructor. We decided in the monthly Rosetta developer teleconference that nobody's really calling the copy constructor on purpose because it's not a very Pythonic thing to do, and if you know about copy constructors, you're probably doing it from C++ and you might know the danger, and it's just, this seemed like the least bad option to solve it. If you disagree, I mean, those monthly developer teleconferences are open to all of us, and that's the place to talk about it. If you disagree in a hurry, you can talk to me sooner, but that's the status quo. We're also trying to find other instances, well, all instances of this in PyRosetta, and frankly, every library that is bound, I mean, this isn't, nothing I showed is Rosetta specific, really. But now there's this unit test. I don't think it's merged in yet, we're working on it, but you can imagine for every function that could be bound into PyRosetta, you can test it. We maintain this green list of approved functions, but if they would cause an issue, but we allow them. I'll talk about that in the next slide. And then we try calling the function with my class, which is a class I made in Python. Doesn't exist in Rosetta. It will throw an exception. The exception message has a list of all the function signatures that would be allowed, so we can iterate through those and look for conflicts at the bottom. And just print them because this is an integration test in Rosetta, so every new print statement is a failed test. This is on GitHub. The gist is just trigger every possible class to fail and give us its list of signatures, and then just brute force it. So we have an open pull request that admittedly I haven't touched in a few months. But we found 276 cases of this, and I got down to 182 before the Q4 deadlines kind of took me away. And it's just a matter of maintaining this green list and iterating through all 276 instances and deciding, is this a problem or is this actually a specialization, which the green list is full of. An example of a specialization is a conflict that is fine. For example, the pose residue typeset has 2 constructors here. The one on the top is just a standard copy constructor. The one on the bottom is also a copy constructor, but for like sister classes where you can't copy everything. It's fine to have both of these because they both have the same intention. At the very least, they're not doing the exact opposite. So we greenlist this, at least for now. But cases that seem to oppose each other, we flag and try and resolve. For those who want to go through the tests later, or if you want to try this out, this is a reproducible example. We just select residue 5, we negate it twice, and we see that the second negation at the very bottom doesn't actually change the first negation. So this code is here for you to try it. That's it. I just wanted to thank Sergey did a ton of work. Rocco, the whole developer community, and especially in the monthly meetings with Julia, David, Steve, everybody really helped discuss this. I recommend anybody who's interested to attend those. I also want to thank the organizers and the conference for giving this time slot, because I'm really scared of this bug and I want to just propagate it as much as I can, even though it's not a research talk. But that's it for me. Thanks for listening. Happy to talk about it during dinner or anything.
Thanks, Jack. We got to be quick about questions. Do we have one? Anybody? Question? Anybody?
Hey, thanks for the only Rosetta talk at the RosettaCON. And then, I guess more of a comment since there's no questions, but how easy is it to put more print statements throughout like Rosetta scripts and PyRosetta? To me, it kind of seems like this is just a sort of warning for everybody just to make sure you print things.
Test your code even when you assume the atomic things should work. Atomic from a code perspective, like test your plus signs, right? And in your unit test, don't just use another plus sign because then they'll both fail in the same way. I actually don't think people are at fault if they fall into this trap, because you should assume your libraries work at least to like the basics degree. But if you really want to be careful, don't trust any code base, I guess.
Trust no one. Okay.
I don't have a good answer. I'm still burned, I think. Okay, thanks everyone.
I've had that one too.
Sorry.
I know I've had that one too.
Yeah, okay.
Thanks, Jeff.